This is a quick video to explain three terms that often show up in linear algebra and vector calculus. That's average rate of change, in particular, of a function over an interval, linear combinations of vectors, and vector decomposition. If you had this function in the Cartesian plane xy, and you were asked to find the average rate of change between this interval x0 and x1, delineated by these green points on the curve, what you could do is superimpose some vectors along the curve that are tangent to the curve that represent the change along each point. If you were to take a linear combination of these vectors, and linear combinations are performed by putting vectors together tip to tail, and then just connecting the starting point to the ending point, like you see here, a plus b equals c, you would get one big vector connecting the starting point to the ending point of the interval. If you then divided that vector up, you would get a constant that equals the slope of the vector. And that slope is your average rate of change over the interval. A couple of ways to illustrate this are via linear combinations, which we already saw. Another way that you could approach it is via vector decomposition, and you can see the same thing. If you have a vector b and you divide it or split it into its x and y components, example, let's say vector b represents, the vector is 1 in the x direction and 2 in the y direction, then b would equal the x vector plus the y vector. I'm writing these as column vectors because that's usually how you see it in linear algebra. I personally take these column vectors, set them up in space just like they look, and then add them together just like you would numbers, letters, etc. It's normal algebra. But anyway, you can see how we've decomposed b into its x and y components. So if we use vector decomposition, and I start with the x's, get a little smidge from the first vector, and then the second, the third, the fourth ends right there, and I keep going, and of course I end up there. Then if I decompose the y element of each vector, I get an increase, oh, then a little bit of a decrease. We go down again, and we go way down, go to the minimum, then we come back up, and we arrive there, of course. So there's our total displacement in the x direction and our total displacement in the y direction. And once again, we connect the two, then we divide it by our units. And again, we would get this same slope that represents our average rate of change over the interval.